Okay, right. So let us go for digital PAM transmission through band limited baseband channel. So what would exactly the channel, the basically what you're doing, a digital communication point of view, what exactly the digital communication point of view is that, so whatever the output signal will come, are your, whatever the output signal, whatever the output whatever the output signal it comes will be split into digital signals in the form of what exactly, in the form of the it will be taken by taking the sample of the output of the channel. So that means, so how exactly it works here, a digital PAM transmission through band limited baseband channel will take the sample of the output of the channel at every t is equal to capital T naught and gives the output. That is what exactly called as digital PAM transmission through the band limited channel. That means whatever the input data will be, so look back here, absolute is very simple, as similar as that. Here, exactly here, okay, here. So here what will happen? So we need to transmit this very important point in digital PAM transmission through band limited baseband channel is not only, okay, exactly, it is not only, so whatever this is the input data, the transmitter will convert what exactly the binary sequence pulses allow the which allow the frequency which is suitable to the bandwidth of the channel. Now basically what we want to transfer, we wanted to transfer the PAM digital what you call amplitude of the pulse amplitude modulations. That means, because look back here, this is absolutely in the input data will absolutely consist of input, then binary sequence pulses. These frequency pulses will be utilized in what exactly one of the modulation techniques, either BPSK or QPSK or FPSK, whatever you desire it, and this signal will be passed absolutely into this transmitting filter. Okay, this signal will be absolutely passed into the transmitting filter. Okay, this transmit filter will limit the frequencies which are easy, we limit the frequency of this, which is limitation of the what exactly within the limitation of the channel, then signal flows. But here what will happen, we wanted to transfer the what exactly, that is even though this is a signal analog, at this point we want to transfer the digital signal, we just what exactly, this is a signal, we are going to convert the what exactly, this is the into a PAM, pulse amplitude modulation. So we take the sample of this is equal to, so that means the output of the transmitting filter here in this we just take the sample of that, we'll get back to V of t into a to the power of n is equal to what exactly, this is the frequency, this is the magnitude of the each split signal multiplied into the what exactly, the input. Okay, exactly, input, that is exactly, this is the output and this is the signal. We are going to split into what exactly, if what you call it as digital signals. Okay, exactly, please mind it, PAM, pulse amplitude modulation is the one, the pulse amplitude modulation is the one which passes the signal in the digital and convert into what exactly, an into g of t minus t. Okay, exactly. So that means once this signal, the baseband signal at the output of the transmitting filter is this. Thus, we are converting to what, discrete signal, that is a digital signal, by with the help of the what exactly, a sampling. Let us not talk about how, because it's just imagine that this in the filter itself is going to, will get back to discrete signal. The whole magnitude of the discrete signal is given by this. Now, absolutely what exactly here? Let us say R of t is equal to, so you look back, this is one of the signal will come. Okay, exactly here. This is the one that is exactly h of t, as I told you, there is a response of the signal of the input. That is exactly what, g of t, which is now input to the channel is equal to v of t. This is absolutely for digital PAM transmutation. That is the pulse amplitude modulations. Now the output of the channel will multiply, in the channel there is a noise, additive noise will be multiplying to the channel itself, and exactly, and it is now this, with this response of the signal by the channel to this will addition takes place. R of t is equal to what? So that means we're getting the R of t output. Now since R of t is equal to this value that is E of t plus noise. So that means output of the channel of the received is equal to R of t is equal to summation integral of minus to the plus infinity a n into h of t here, because the response, look back here, this is only we splitted the input signal into discrete, where exactly we had taken at this point h of t is equal to response of each splitted discrete signal as an impulse response. That is why we have taken into what exactly n is equal to e minus into the plus infinity a n h of t minus t into plus n of t. So that is exactly here the impulse response of the cascading transmitting filter and the channel. Okay, cascading transmitting filter and the channel here, exactly this and this will be learned. So now h of t, absolutely h of t is equal to absolutely conversion property, because when you time domain can be converted into what a frequency domain. So by using convolution property of the Fourier transform, I can write h of t is equal to what exactly c of t, that is a response that is impulse response of this into what are the input signal, frequency input signal, and what exactly here c of t into h of t. Okay, right, that is exactly n of t. All right, so now see, look back, what will happen? So for the output of the filter, so the output of the receiving filter, so that means output of the receiving filter, this plus this output of the plus omega, this simple, this is as I already mentioned here, already mentioned in this point. Okay, exactly here, look back, the output exactly h of t is equal to c of t into this is the output. Okay, so similar output has to be constructed at the output level at this point, because after the receiver filter, the receiver filter is, I told you that the receiver filter is the filter which is equal to exactly the input model, that is the input to the water, input to the demodulator, the first input to the receiver, first block of the receiver is equal to this. So that means absolutely, which is as Gomez as given in the previous explanation, the y of t is equal to here, the y of t is equal to summation n is equal to infinity plus infinity x of n. Okay, a n into x of n t minus t plus omega t. So this, when you take the response of this, so this is exactly x of t is equal. Okay, so exactly x of t is equal to h of t, this is okay, the output of the receiving filter. Yeah, exactly here. Okay, exactly. Y of t is equal to this much. Y of this is let's continue. There is some disturbance is there here. Y of t is equal to what exactly? Summation n minus n is equal to minus infinity the plus infinity a to the power of x of t plus 1. Okay, so this is absolutely y of m is equal to e to the summation n is equal to minus into the plus, this is output. So when you take just taking this instead of making n minus t, so in n minus 1, this is absolutely the output. And the response of the output signal can be response of the impulse response minus infinity the plus in h r square of t into minus infinity the plus infinity h of square into d of is equal to what? The energy of the signal. So this is what how exactly goes in the transmission. The very important things here, only thing is after the receiving the y of t, okay, exactly taking the sample of the response of this is at every stage of this, y of t will also consider, because look back here, the response of the signal here, absolutely response of the signal is response of the match filter. will be absolutely get affected. Y of t here again the same output will be split into out exactly pulse digital modulation techniques. So we'll get back to the output as simple here. I mentioned this is the output of these things. Okay. Okay. Next class we'll continue the discussion on this. Okay. Fine.